As we can see that mineral exploration is characterized by a number of factors that distinguish from other resource sectors such as forestry, hydropower. Minerals are the such resources that cannot be moved, but they are at a location which may not be convenient for a resource plan. Once we find some resources in some area, that area can be developed as a cluster of mines, as in case of NMDC Balladilla sector. Defining an economic mineral deposit is time-consuming, costly, and highly risk, requiring the advanced use of technology. We see that the supply is very much limited, and the resources is from the supply. And out of the resources, the reserves are the subset of the resources. We need to improve the influence of area of the reserves. There are mainly two reasons for deviation from the reserve. There is one is the poor grade estimation, and second is inadequate dilution and mining losses. Some of the factors which are important for such grade estimation is inefficient data. Now I am coming to the topic. The first law of earth science is that everything is related to everything else, but the near things are more related than the distant things. It is natural that nearby places have similar climate as compared to places which are far apart. Using this theory, we are using the variogram for grade estimation. Estimation is a complex process as the numerous contaminants all have a different grade distribution and different degree of variability. At this time, we need to use the variogram for iron ore resource model. Semi-variogram was first used by Marson in 1963 for predicting the iron ore grades in South Africa. Other usage of variogram is in mineralogy, meteorology, environmental monitoring, and epidemiology. In deposit 10, we have used 16,192 meter of the total drilling. We have prepared 12,336 number of sample. The minimum depth was 12 meter and maximum was 203 meters. This is the all steps we have followed by estimation of the ore body, including the variogram generation. Next, please. You can just find the different boreholes located over the surface topography of deposit 10. This is the next all section prepared while doing the grade estimation and block modeling. Next, please. Next. We have prepared the solid model of different ore type of the body. Next, please. This is the final solid model of deposit 10 that we have prepared. We have made the composited samples. This is the result of one of the composited sample. We have also applied basic statistics to remove any data which are not acceptable in grade estimation. We have used the variogram model. This is one of the graph of the variogram model for grade estimation. This is the final ore body in form of different small size blocks. We have now estimated, and this plan shows one of the grade plan at 1128 MRL of deposit 10. This is the mineable reserve of deposit 10 after grade estimation. From this result, you can see, sir, that for one type of ore, we can know the grade at a different level. At 12 meter interval, we have defined the grade of type 1 ore, what is will be the Fe, alumina, and silica and alloy content. So by doing this variogram modeling and grade estimation, we have defined the ore model likewise. This is the Fe grade that we got after grade estimation, different class of ore, type 1, type 2, type 3, showing the different grade. Next, please. This is the alumina grade of the ore body. Next. This is the alloy. This is the silica grade of the ore body. We have generated 80 number of pits based upon this grade estimation, and we have selected one of them as our optimum pit. This is the excavation trend that we have defined after the grade estimation. And this is the ultimate pit map of the ultimate pit. We can see the NPV, life of the mine, payback year, internal rate of return, everything has been defined. This is the ore to waste ratio for ultimate pit. And finally, we have concluded that this will be the great tonnage for our deposit. If we mine everything above 55%, then we can mine up to 260 million ton. If we go for selective mining of 60% and above, then it will be around 190 million. So to sum up, I would like to say that the database was the core of all these activities, and next was the block modeling, and the final one, the final curve is the optimization and scheduling for all these work.